your slideshow next to it. All right, so likelihood and probability, that's what we've been talking about, right, the past week. So let's go ahead and review a little bit. All right, so the first thing we talked about was likelihood, right? Even before we got to fractions and percentages like we have here, we said that there was different words we could use, and it doesn't have to be these exact words, but there's words that we use to kind of represent and get our mind around what likelihood is. So this first one, I'll go ahead and give it to you. This one was impossible, right? Because if this can never happen, it's going to have a 0% chance of happening, or as a decimal, that's still 0, right? And as a fraction, also 0. Okay, so it's impossible. There's no way it can happen. Now, this is where I'm going to have you guys interact a lot. What do you think these next two are? You can go for the next one, just the next one, or the next two if you want. So in the chat, I want you guys to go ahead and quickly write 2 words that you think could represent this second column and the third column. If this one's got looks like a 4th chance of happening, 20%, and this one's got a half chance, a 50% chance, what could we say about these? Oops. Okay, good. Preston says not likely. Let me get some other responses. Just real quick. Type in what you think. Okay, got another unlikely. Anybody different? And again, it doesn't have to be an exact word, right? There's no exact correct answer on this. Okay. Not likely, unlikely. Okay, good. So this next one, yeah, is going to be something like unlikely, not likely, just like you guys said. Then this one, we could say as likely as not, a half chance of happening, something like that. Because there's a half, as a fraction, it's a half or 50% chance, right, of happening. All right, and then certain, and this is a big one too, as a decimal, impossible is 0, and certain is 1 whole. So 0.5, 1 whole, right? 4 out of 4, that's certain, 100% will always happen. Okay, and then what could this other box be? In the chat, I want you guys to write what you think this last box is. Ready, go. Sorry, any guesses okay? Anybody else? 5, 4, 3, 2. Okay, you guys are correct. Okay, so this is going to be likely. All right, and again, these aren't exact words. On the CFA, we'll use the same words to keep it simple. But you got likelihood is anything from impossible all the way to it must happen. So you've got this different range of possibilities. Alrighty, so let's roll on. So let's try this out. I want you guys to go ahead and answer this on your own if you're following along here. It says a jar contains 320 flies, 284 ladybugs, and 133 mosquitoes. If you close your eyes and picked an insect from the jar, how would you describe the likelihood that you picked a wasp? So if you have a jar with 320 flies, 284 ladybugs, and 133 mosquitoes, if you close your eyes and put your hand in the jar, which seems like a bad idea, in my opinion, I wouldn't put my hand in a jar of insects. But if you did, and you have no fear, and you're grabbing an insect out, what is the likelihood that you pick a wasp? Is it going to be certain, likely, or impossible? Okay, I got 2 votes for impossible. Anybody else? Let's get a little bit quicker on the chat here, guys. I think several of you guys were in a group the other day where we were just going real quick. So just type in the chat, click enter. Good, thanks Briggs for responding. Thanks Cadence, Preston, Abigail, thanks. Okay, impossible. All right, so the correct answer, and I don't know if I switched this correctly, but it is going to be impossible. Very good, guys. If this jar doesn't have wasps, we can't. If we stick our hand and pull out a random insect, it's not going to be a wasp, right? Impossible. Very good. All right. Oops. Next, pretend you didn't see that. For the spinner shown below, select the probability of spinning blue. Okay, so if we have a spinner and we go, okay, what is the probability of spinning blue? Is it impossible, unlikely, even chance, likely, or certain? Okay, good. We got an unlikely, unlikely, even chance. Nice. All right. So, yeah, if we spin it, and these little numbers here, I think are trying to give us a clue of like how many toggles are in here. Like this one's got 9, and this one's got 1, and this one's got supposedly takes up 2 spaces. But just by looking at the size of these, this is gonna be a lot. This is gonna be like a jackpot, probably, right? The blue one. They're not gonna have this big section be like the best prize if it's a prize game or something. So yeah, blue is gonna be not impossible because you can still land on it. It's not gonna be certain. It's not gonna be 50-50 really, right? That would be maybe if we had here and there. But it's gonna be unlikely. It's unlikely that they'll land on blue. So good job, guys. It is gonna be unlikely. If that's what you said, you are correct. All right. Good. So moving forward from that, we then talked about experimental probability or observed probability. So this is the science of what did happen through observation. So experimental probability says the probability of an event happening equals the observed frequency of the event over the number of observed attempts. So for example, we could say the probability of getting heads, and then over here we could say like it happened 7 times out of a total of 10 flips. So the probability of that would be 70%, because that's the experimental probability, right? Because we know a coin theoretical probability would be 50-50, but in that case, we flipped it, and 7 times we got heads, so that would be 7 out of 10 probability. Okay, so, and here's another similar example. We flip a coin 25 times, and tails shows up 9 times, we could write it like this. Probability of tails happening for experimental probability would be 9 out of 25 times. And so then our probability would be 9 out of 25, or 0.36, or 36%. Okay, you can get these two numbers, guys, if you need a percentage, by dividing these two numbers. Okay, so that's an important note, is experimental probability always going to be the same as theoretical probability? What do you think? You can just say a yes or no. Is theoretical probability always going to be the same as experimental probability? Okay. What else? Who else? What do you guys think? Thank you, Preston, Briggs, Abigail. I got you guys. All right. No, it's not going to be the same. Good, guys. Yeah, just like we just said, right? If we flip a coin, my expectation would be that I'd get heads 50% of the time, right? Or tails 50% of the time. But when we did this experiment, it's not exact, right? 36% of the time we got tails. But the more we do it, if we flipped it another 100 times, then it would get closer and closer to 50%. And we did that experiment together, right? Excellent work, guys. You're doing great. So here's another experimental probability. If we have a spinner that has these 4 sections, and we spin it 48 times, that's a lot of spinning. My arm would probably get tired. But if we spin that thing 48 times, and we get these results, okay, A, B, C, B, 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 C, C, okay. Based on the experiment, what is the probability of spinning a C? Okay, this is where I want you guys to step in on your own. I want you guys to find the probability of spinning a C based on the experiment. Okay, so you're probably going to do some counting, right? Count up the C's. Okay. Good, and yeah, let's say this. I'll give you guys another like 30 seconds. Don't post your answer just yet, and then we'll all post them just at the same time. All right, and about 5 more seconds. All right, go ahead and put your answer in the chat and press enter. Show me what you guys got. Good. So we got some 25%. All righty. Oh, okay, so it seems like almost everyone put 25%. So let's check it out. So now here's the thing to check. So we've got a spinner, right? The theoretical probability. So we can do the theoretical even easier. Theoretically, we've got 4 sections, and they all look the same size, right? So the probability of landing on a C, theoretically, should be about 1/4 of the time, right? So should be about 1/4 of the time, which is 25%. And I'll show that here, right? So 1 out of 4 times should be about 25%, right? Or exactly 25%. Now let's see if the experimental probability is the same. So that's what this says. Based on the experiment, what is the probability of spinning a C? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so we say 12 out of 48 total times, right? And again, that's 0.25, 25%. So this time, the experimental probability ended up being the same as the theoretical probability, didn't it? Okay? And part of that reason is they spun it 48 times. The more you do it, the closer the two will become. Okay? Good job, guys. So how many in C? We said 12. So probability of spinning a C based on the experiment is 12 out of 48, or 1/4. Good. All right. Next one. I want you guys to, I'll give you guys again, about a minute or a minute and a half. A bag contains red marbles, white marbles, and black marbles. Without looking, Jackson removes a marble from the bag, replaces it, and then removes another. He repeats this process 900 times. So Jackson's got a lot of time on his hand. Maybe he's in quarantine. And he's just pulling marbles out, putting them back, pulling them out, putting them back, okay? And he's recording the results. So what is the observed probability of removing a red marble from the bag? Okay, and actually we don't need as much time as I said. So take about 20 seconds. What is the observed probability of removing a red marble from the bag? So based on the experiment. What do you guys think? Okay, nice. Preston's quick on the ball. You get, yep, you guys can go ahead and answer too, as soon as you get it. Good, thank you, Ulysses. Okay, good guys. Good food.
You have food? Yes, I have.
Okay, awesome. Just one second. Pretzels. Just this. All right. Yes. All right. Thank you. Good job. So we've got. Sorry, a little distracted here for a sec. Sorry. Okay, so all right, so I've got 25% from some of you guys, 29, 30. So let's see what it is. All right, so we said how many reds were removed? 260, right? And how many tries were made? 900. So that's going to be 260 out of 900, right? The number of times we got it out of the total possible. So then we're going to divide those two and see what we get. 260 divided by 900. So 28.8% approximately. Okay, so we could round that up to 30, or so you guys said 29%, 25%. But If it's 0.28888, that's going to be about 28.8%. The closest thing to round to would probably be 29 if we were going to the nearest percent. All right, good job, guys. Excellent. So this is the science of what should happen, right? This is now theoretical probability. And we talked about that first last time, I think. So if we have the theoretical probability of an event, again, we could write it the same way, P parentheses and then the event. The number of ways the event can occur go on the top, and the number of equally likely outcomes go on the bottom. So, so let's check that. Sorry, it'll be easier if I show you what I mean. So flipping a coin is considered fair because there's two outcomes, heads and tails, right? As we even did ourselves in class, right? So only one time tails will happen. Sorry. Yeah, only one time tails will happen on a single flip. So probability of tails is going to be 1 out of 2, right? There's only one way to get it. So number of ways an event can occur. There's only one way that you can get tails, right? And there's 2 total outcomes. So 1 out of 2 equals 0.5 or 50%, right? So that was theoretical. We didn't have to do an experiment. We didn't have to flip, flip, flip. We just had to think about it, reason through it, know what the situation was, right? All right, so once again, I'm gonna have you guys interact here. That way I'm doing less talking. A 6-sided number cube, also we usually call it a die, right? Is rolled. What is the probability of rolling a 4? Go ahead and respond in the chat. Okay, got a couple of responses, good. Okay, good. So 1/6 chance. If it's a 6-sided die, right? And it's not rigged. Excuse me. There are rigged dies in the world, and that's pretty tricky. That's when people have a die that always lands on a certain number. But probability of rolling a 4 is going to be 1/4. I'm saying 1/6. Okay. All right, now what is the probability of rolling an even number? Probability of rolling an even number. Okay, interesting. Good, good. I got a couple different responses. I like it. All right, and let's see. So we've got a 6-sided die, right? It can be a 1, 2, 3, 4, 5, or 6. And if we're looking at the probability of rolling an even, so 1, 2, 3, 4, 5, 6. So that's 1, 2, 3 out of 6 total, right? So we would say, what's the probability of rolling an even? It's going to be 3/6, right? Or 1/2 is going to be the probability. Okay, so 50% chance of rolling an even. Okay, which also means it's 50% chance of rolling an odd, but we weren't asked about that one. All right, 1/6 is also 16.7%, or half chance on that second one. All right, so a box contains four blue balls, 3 red balls, and 4 yellow balls. What is the probability of picking a yellow ball? So again, there's no experiment being done here. What's the theoretical probability then of picking a yellow ball? What do you guys think? Okay. All right, a lot of 4 out of 11s, 36%. All right, let's check it out. So number of yellow balls. There are 4 yellow balls, right? And how many balls are there total? Well, we got 4 and 4 make 8, and then 9, 10, 11. So there's 11 total, as you guys already know there. So probability of getting yellow would be 4 out of 11. This becomes about 0.363636 repeating. So that's about 36.4% if we're rounding to the nearest 10th. So good job, guys. You guys all said 4 11ths, which is the same as this percentage here. So you guys all got it right. Good job. All right, so okay. Oops, I didn't mean to send that. Okay, so, all right, good job, guys. So this brings us to the last thing that we studied on probability, which is predictions. So that's when we put on our little turban and we say, I can read your future. Because we can use probability to make predictions about the future, and sometimes they can be very accurate based on what we've seen. So known probabilities are those, again, using theoretical probability, and observational probabilities are those we can find using experimental. Okay, so basically this goes back to what we said when we first talked about predictions, and we said that not everything can be experimental and not everything can be theoretical. So for example, we can't get the theoretical probability of, I don't know, putting a person on Mars, per se, because that's not possible yet. So there's not really a way to do that. We also couldn't, we couldn't do experimental probability of that. We could maybe do theoretical and try think our way on that, but we can't experiment with that because there hasn't been a person to Mars. There are some that are the opposite way around, where there's no way to, like we did that basketball activity with you guys, again, that's a good example. I can't say Ulysses or Abigail, the probability of you making a basket is 1/8. I can't just like come up with that in my head. If I keep a tally of how you score, right, and see like your shooting record, then I could make a guess, a hypothesis, right, based on the experimental probability. But I can't have a theoretical probability for you shooting baskets because it's not something that's set in stone. It's more fluid than that. Unlike these, where we know, oh, there's only 2 sides, or there's only 6 sides. All right, so not everything can be both. All right, so 2 ways we can predict. What is the likelihood next try? So that's the thing we can predict. What's the likelihood on the next try? And then another thing we can find is how many times would you expect certain event to happen in 100 more tries or in 10 more tries. So let's try it out. So we've got Sam here, and he drove through an intersection near his home 40 times. he had to stop for a red light 30 of those times. Okay, so what is the probability that Sam stops at a red light on his next trip? So what do you guys think? So this is an experimental probability because we have some scores, some results, right? He had to stop 30 times out of the 40 times he went through this intersection. What is the probability that he'll have to stop at a red light on his next trip? Think about your answer, and then I want you to go ahead and respond. Okay, we got one response. What else? What do you guys think? All right, got several 75%. Good, that is correct. Okay, so it is going to be 75% because 30 times the event happened out of the total 40. So that means that the probability is going to be 30 out of 40 for his next try, okay? If it's just looking at the next try. All right, now, what is the expected number of times Sam will stop for a red light if he drives through the intersection 100 times? Ah, okay. So you were correct if you said 75%, 30 over 40, or I'll write that in here, 30 over 40, or 3/4, right? Or 75%. That's all the same way of saying the same thing. So based on that, okay, what is the expected number of times Sam will stop for a red light if he drives through the intersection 100 times? When you get your answer, go ahead and post it. You guys are doing so well. Good job. All right, what do you guys think? I got 30%, I got 75. What do you think? How many times do you think he'll have to stop for a red light? All right, if you're still thinking, that's okay. So we take the information that we got, the probability of stopping at a red light on his next trip, right? So the probability on the next trip, based on the observation, we said about 75% chance that he'll have to stop, right? So we take that same thing and we can try to predict in the future. So if we say, if Sam's going to drive through this intersection 100 more times over the next month, then about 75% chance of that, or 75% of the time, he'll probably be stopping, right? So I take my calculator and I say, okay, it was a 75% chance or 3/4 chance, right, of this thing happening. And then I multiply by the number of times I'm predicting. So I'm taking basically taking 75% of 100 times and seeing what I get. So 75% of the next 100 times would be 75 of those times. Okay. So the answer would be, we can predict about 75, I'm gonna write it here, about 75 times out of the next 100 times that he goes through the intersection, to the intersection, he will stop on a red. Okay. So we take our probability and we multiply it by the number of times we're predicting. Okay. All right. Excellent job, guys. Let's move on. We're nearing the end here. So 3/4, that's what we said there. 3/4 times 100 gives you 75. All right. We weren't as confident on that last one. That's okay. This is probably maybe the trickiest of the stuff we covered. So 80 spins were tried on the spinner. 12 times it landed on green. What is the probability it lands on green on the next spin? So just the very next spin, what's the probability? Take about 10 seconds to think about it. And then I want you guys to post in the chat. All right, go ahead and post in the chat what you think. 80 spins were done on the spinner. 12 times it landed on green. So what is the probability that it lands on green on the next spin? And again, it should say, what is our prediction? What's our prediction that it'll land on the next spin? All right, got a lot of the same answer. Good, so we're using theoretical probability. Okay. So here's the trick on this one. Okay, guys, it may have led you astray. On this one, it didn't say what can we expect based on the previous results, or what did we expect based on our observation? Okay, so because this is a spinner, guys, because there can be a theoretical probability, that's going to be the most reliable source of information. So I'll say that again. Make sure you guys hear this. Since this is something that's we can have a theoretical probability, like a coin or a die or spinner in this case, we know that each time you spin it, there's always going to be 1, 2, 3, 4, 5 chances in this example, right? There's only 5 possible results. And each time you spin it, you have a 1 in 5 chance of getting any of these, okay? So that's this was kind of a trick question here. But you can use theoretical probability to find the probability that it'll land on green on the next spin. So it doesn't matter that it landed on green 12 times, okay? So it doesn't necessarily matter. This would be if we base it off of our observations. But 1 in 5 chance, okay, is actually a 20% chance of it happening, okay? So probability of getting green on the next spin is going to be 1/5 or 20% chance of landing on a green. Okay, so I know that's a tricky one. Okay, because I kind of led you to believe from that last one. But just know that if there's a theoretical probability and it's asking about the very next spin, you always want to go with the theoretical probability. Okay, so let's look at one more here. So if 200 spins were tried on the spinner, how many times would it be expected that it would stop on red? Okay, so we don't have any, we don't have any observations. Okay, we don't have an experimental probability, so we're going to use theoretical once again. So just like the intersection one, if we do 200 spins on the spinner, how many times would it be expected that it will stop on a red? Based on our theoretical probability. Good, okay, I've got Preston saying 40. Who else? What do you guys think? All right. All right, I'm afraid I scared you off now, guys. Don't be afraid. All right. So let's see. For sake of time, we're going to keep on rolling here. You're still figuring it. That's okay. So 1/5, there's a 1/5 chance of spinning a red on this, right? 1/5 for each of these colors. And if we do it 200 times, we say, what's the probability of it happening once? 1/5 times the number of times that we're doing it, 200. And so we say 1/5, my ability to answer. 1/5 times 200 is 40. Okay, so good job, guys. 40 times we can expect it to stop on red based on the theoretical probability. All right. So once again, use theoretical probability. If the red number cube above was rolled 150 times, how many times would it be expected that a 5 would be rolled? Okay, so if we roll it 150 times, we can assume that 1/6, right, is the probability of getting any of these numbers. So we'd say 1/6 times 150 times, right? And so 25 of those times out of 150, it would be expected that we'd roll a 5. So 1/6 times 150, 25 times. Okay. And again, it would be different if it gave us some experiments like this last one. Let me go back real quick. It'd be different if they gave us some results like this one. And Sam went through the intersection a certain number of times and we based it off of the observation. But this one, it asked us to use theoretical probability. And if we have theoretical probability, that's what we're going to use first. Okay. Any final questions on that? Seeing, are you gonna shake your head no? All right. Feel free to ask. Okay, now's the time to ask because we're gonna take our little CFA and then you guys will be done for today. All right. While you guys try to think of a question if you have one. If not, I need you guys to do a couple things real quick. Number one, I need all of you guys to quickly put your first name and and last name's initial in the chat. So if my first name was Mr., I would say Mr. E. Yep, press an R. So go ahead and just put that in the chat real quick. That'll make it easy for me to kind of take roll when I go back and check it later. Okay, while you guys are putting your name in the chat there for me, which I really appreciate, thank you. The other thing real quick, since I got you guys all on here, if any of you guys are using the Google Classroom app, I noticed, at least from my end, that if there's an announcement, like all of our things in the stream are announcements, you can't see the full message unless you click on like make a comment and then it shows you. So just FYI, if you are using Google Classroom's app on your phone sometime, just be careful. Not all the messages are full unless you click on them. So that was one thing I noticed. And then the other thing is we're gonna take our CFA now. I wish you guys the best of luck. Make sure if you are behind on any of your IXLs and I'll show you guys this real quick. or any quizzes. Those are the two main parts of our grade right now, other than the CFAs. Make sure that you're not missing any of those or behind on any of those. Since we're taking our CFA today, that means tomorrow you don't have anything for math, right? So if you're behind on anything, that'd be a perfect time to catch up. So I'll share this document with you guys once again. This is our online class page. Okay. It looks like this, right? You guys are 7th grade, so in the red. So in here, if you're not sure what was for a grade or what you needed to do, this one, see, it says take quizzes. This one, we did this class, and we had that experiment. This one, we did a quizzes, and this one had a couple IXL. So make sure that you guys are caught up on those. Okay, so here's the link for that document. If you don't know where to find it, I would save it. All right. So that first link is the info for class, and here, this